Alright, so the Pythagorean theorem is probably something you've already encountered in 7th grade a little bit. You've learned that a squared plus b squared is equal to c squared when given a right angle triangle. So if you've got a, b, and c on a right angle triangle, your Pythagorean theorem says that a squared plus b squared is equal to c squared, and that means that the square of each side, when added together, is equal to a bigger square created by the hypotenuse of the triangle. Now, the Khan Academy problems give you a mixed radical number, so you've got you will have square roots in here because of the theorem. You want to figure out what c is, not c squared. So taking the square of both sides will give you the square root of a squared plus b squared to be equal to c. So in this particular problem, you've got a equals 6, and I can't see that. So a equals 6 and b equals 8. So c is equal to the square root of 6 squared plus 8 squared, and that's equal to the square root of 36 plus 64. Okay, it helps to work that out. First of all, 36 plus 64 is 100. The square root of 100 is, of course, 10, because 10 times 10 is 100. So now that you've got the answer 10, that will actually go outside the radical, because you don't have a square root left. I will show you in another problem about when you've got the square root left. So there you go. Next problem, we have the hypotenuse in this problem, so we need to manipulate our Pythagorean theorem a little bit. So we've got a squared plus b squared equals c squared, but we already have a and c. Okay, so we're looking for b squared. So if we subtract a squared from both sides, we're going to get b squared equals a squared, equals c squared minus a squared. Okay, so b squared equals c squared minus a squared. And that's only because we just subtracted the a squared from both sides. It's an equation, so long as we do the same thing on both sides, the equation remains true. Okay, so if we square both sides, then we've got b equals the square root of c squared minus a squared. And that's what we're going to work with from here. So b is then equal to the square root of, I believe that's 10 squared minus 5 squared. Numbers are very small there, which is equal to, of course, the square root of 100 minus 25, that's a 5, which is equal to the square root of 75. Now, square root of 75 is not a rational number, so we need to find out what parts of it are rational and what parts are irrational. So we're going to do a factor tree. 75 is 5 times 15, and 15 is 5 times 3. Since we have two 3's, the square root of 5 times the square root of 5 is equal to 5. So that puts a 5 on the outside, and we have a 3 on its own, and anything left on its own must go back into the radical. So our answer is 5 times the square root of 3. Okay. On this problem, we've got a is 8 and b is 8, so we've got two that are exactly the same. Again, we're going to use a squared plus b squared equals c squared. This time we don't need to manipulate anything. We can just say that c is equal to the square root of a squared plus b squared. Right? Just squaring both sides so that we can get rid of the square of c. Okay, so c is equal to the square root of h squared plus 8 squared, and that gives us c to be equal to the square root of 64 plus 64, which is equal to the square root of 128. Now, 128 is a very interesting number because, of course, it is a power of 2. It's one of those numbers that is a power of 2. So 2 is our base, and you can see 2 times 64 is 128. 28 is 2 times, or 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 2. 8 is 2 times 4, and 4 is 2 times 2. And that, of course, we've got just a ton of 2's there. So taking the 2's in pairs, because of square root of 2 times the square root of 2 is equal to 2, we see we've got 3 pairs of 2, so that is 2 times 2 times 2. So that will give us 8 on the outside of the radical. And then inside the radical, we've got a 2 remaining. Okay, so this 2 here that is remaining, that must go inside the radical because there isn't another 2 to multiply. There isn't another square root of 2 to multiply at times. Okay, so our answer there is 8 times the square root of 2. Now in this problem we have BC is equal to 3, AB is equal to 8. We notice when we put in A, B, and C, A squared plus B squared equals C squared is of course our formula, our Pythagorean Theorem. We have C, we have B, we're looking for A, so we've got to subtract B squared from both sides. Okay, that'll get us A on its own, and therefore A squared is equal to C squared minus B squared, and A is going to be equal to the square root of C squared minus B squared. So that's what we're going to work with, working with that, we've got A is equal to 8, the square root of 8 squared minus 3 squared, which of course is equal to the square root of 64 minus 9, and 64 minus 9 is 55, so we've got the square root of 55 to work with. Again, 55, not a rational number. Let's do our factor tree. 55 is 5 times 11. Both 5 and 11 are prime numbers, so we cannot extract any of this from the equation, so from the square roots. We put 55 back into the square root.